Yay! Thank you very much for inviting me to your fantastic city. It's not only the first time I've been in South Korea, but actually the first time I've ever been in Asia, so it's a fantastic experience to be here. I'm a bit of an imposter, I guess. I'm not really Cambridge University. I am an alumni of Cambridge University, and I continue to teach and collaborate with the students there to bring the idea of sustainable development into the engineering courses. As a young engineer, I really wasn't taught about sustainable development, even at one of the top learning institutes in the world, as Cambridge University is. And so I feel it's important to bring a practical example of what engineers can do and should be doing in this society to improve the sustainable development of our built environment. The first quiz, thank you very much for most people getting it wrong. The lady in red that did get it right. People don't really relate to the fact that one of the most wasteful things we do is build things, and we are all responsible because we all live in a home, we all use the schools, the hospitals, the roads, so we do have a responsibility for that construction and demolition waste that we are creating. I spent 4 years working on the Olympic programme in London, and I know that South Korea has just finished an Olympic programme as well. The Winter Olympics. So I'm just going to take a little bit of time to talk to you today about some of the philosophies that were applied on the London Olympic programme and perhaps some of the missed opportunities that we should now be thinking 10 years on, we should now be thinking about applying to our built environment. So just a very quick summary of some waste statistics in London and the comparison with Seoul. You'll see that per person, per capita, Seoul is actually quite efficient in terms of the waste it's generating. We actually generate more waste per capita in London than you do here in Seoul. One of the interesting things that I saw was that in London about 50% of our waste is construction and demolition waste. In Seoul at the moment that's as high as 75% of your waste. So per capita, London and Seoul are actually producing the same tonnage of waste in construction and demolition as Seoul, which suggests to me that Seoul is a city that's developing, it's growing. We are replacing old buildings with new buildings. The city is growing, the infrastructure is growing, and that's why we're creating quite so much waste. What you will see in the pie chart there as well suggests that although we create a lot of construction and demolition waste in London, we're very, very good at recycling it. We don't put much waste to landfill. Municipal waste, you'll see more of that. That's more challenging, although we're creating less of the waste. A lot more of it is actually ending up in landfill. We're losing the value of those resources. So the London Olympic Park, this is what it looked like in 2012. And I think just picking up on the last speaker, the thing that London 2012 tried to do very hard is to restore a forgotten piece of land in London. It was contaminated, it was degraded, there was a few businesses there, 300 odd buildings, most of them derelict. Very little was happening in that area in London. So the restoration idea was very critical. The waterways that you see running through the park were contaminated, they were dead, nothing was living there. So we tried to open these back up for the public to appreciate the landscape and to enjoy the waterways, but also to bring it back to life in terms of ecology. And now we're finding kingfishers, we're finding otters, we're seeing an incredible variety of animals moving into the Olympic Park. So this is what it then looked like after the Olympic Games. This is pretty much what it looks like today. And you'll see that a lot of those temporary buildings, the hockey pitches on the right-hand side, the basketball arena, they've disappeared. And this is what it will look like in the future. This is housing, residential, schools. There's a health centre going in, trying to regenerate and create a vibrant neighbourhood in that area. So this will continue now for another 10, 15 years. The Olympic Park in London is not complete. It's still very much a work in progress. But I'm going to take you back to 2006. These are some pictures of what the park looked like, my first visit. We had a mountain of fridges on the aquatic centre site. We had, you can see the disgusting sort of nature of the waterways there, really thick with contamination, whether it's coal tar. We had heavy metals like arsenic and cadmium. We had radioactive materials. It was really a heavily polluted site, and a lot of fly tipping waste, a lot of dumping was happening on the site as well. So the first thing to do was clear and clean that site. We had to take down about 320 buildings, a few of which we were able to deconstruct and reuse. So this is an example of a steel portal frame, a very, very deconstructible, intelligent building. You'll see the doors, the windows coming out, the purlins. You'll even see the air conditioning units. And all of that was actually then sold for £150,000. So it made money. And also, if you have a look at the carbon, the embodied carbon in those materials, there's about 290 tons of carbon saved, rather than it going the route of recycling. So the importance of reuse in the whole philosophy of the circular economy is really quite important, more so than recycling, because it means we retain the value, the financial value, the embodied carbon value, the ecological value of our materials. So we really need to be looking at the reduce and the reuse before we even consider the recycling aspect. So this is kind of the waste hierarchy. I prefer to think of it as a material hierarchy, because if we start thinking about waste before we've thought about material use, we're already in the wrong area. We need to be thinking about materials in the first instance, eliminating how much materials we use. The most sustainable material is the one that's never used. It's the one that we leave in the ground for future generations. If we look at reuse, sorry, I've missed one there. We're looking at reduction. So this idea is some research from from the University of Cambridge suggested that actually every single building we build in the UK has 15% more steel than is necessary for the structural nature of those buildings. So we're putting too much materials into our buildings to do a physical job. And I dare say that that is repeated across the world. So we need to look at the efficient use of the materials that we are using, not putting materials in a building because we're not sure whether it's quite right structurally. We've got the computing power now to create very efficient structures. We need to be using it. On the reuse side of things, buildings have an end of life, but actually the materials maintain the performance. So for example, a steel beam in a building, the building may no longer be useful in 60 years' time, but that steel beam will still be a steel beam and still be useful as a steel beam. The plastic pipes, all of the plastic that we've ever created in the world is still in existence today. So a plastic drainage pipe in my building, even 60 years down the line, could still be used as a new plastic drainage pipe. So we have to start thinking about how buildings can be deconstructed, how we can take that steel beam out and use it in a new building, not take that steel beam out, melt it down and create a new steel beam. It's a far more complex and difficult idea, because we're looking at designing things for 60 years' time, for 100 years' time. Buildings last a long time. It's a change in philosophy. There's some research happening at the moment in Europe, building as material banks. And the idea is that those buildings that we're creating become a deposit for those valuable products, the steel beams, the concrete, the glazing. We're putting them there for safekeeping for future generations to use, rather than simply building a building and thinking about demolishing it and recycling it at the end of life. And again, we have the technology to start tracking some of these details, tracking some of this information, but it's applied very, very badly at the moment in industry. So finally, let's have a look at recycling. This is the stage that we've had so much focus on in the last 10, 20 years. But the reality is very few things are actually recycled. They're downcycled. So for example, when I finish with this building, the concrete floors, we can downcycle the concrete, we can crush it and use it as aggregate. But we're not going to take the concrete and use it as new concrete. So I've lost the value of that material, both financial and ecological value of that material. And we see this happening a lot. Very few things are able to be recycled, genuinely recycled. We see them being downcycled, 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 until potentially they end up in energy recovery or landfill. In energy recovery, there was a big focus on energy from waste, this idea that it's renewable energy because we're just burning waste. My problem is that as soon as you build an energy from waste facility, it needs feeding. And it needs feeding for 20, 30, 40 years. You're tying yourself in to an idea that is decades old if you're building an energy from waste facility now. Because nobody will come and operate that energy from waste facility unless you guarantee that they will have waste to burn for the next 20, 30, 40 years. So the idea that we're still putting energy from waste facilities in as part of a sustainable waste management system actually disturbs me a little bit and upsets me, because they will be there for decades to come. And then, of course, the last thing is landfill. Although I guess we're not quite as tight as Korea on space, we have a problem. We have run out of landfill space in the UK. So landfill really is not really an option and should never be an option. So let's have a look at how this philosophy was applied on the London Olympic Park. In terms of eliminating, a lot of lightweight temporary structures were used for those sports that we felt that there was no permanent use for the buildings. So here you see the shooting gallery, you see the basketball arena, the temporary stands from the aquatic centre. In theory, yes, it reduced the material use in the first instance. We built less, we built lighter weight structures and buildings. But most of those elements were recycled after the Olympic Games. So all of those elements were just there, and all of that material was used just for the 6-week period of the Olympic and Paralympic Games. So the life cycle of those materials was incredibly short. I'm not sure we have the right temporary solution. I think temporary needs to be part of Olympics, but it's very exciting now to see that Paris and LA have been awarded the Olympic programme at the same time, because perhaps we have the potential to work with Paris, to work with LA, and say, if we are going to build a temporary basketball arena and you need a temporary handball arena, can we work together to understand how those arenas can start to move around the world and be adapted and reused, rather than every single country every 4 years having to create something new and something potentially very wasteful. We're now going to have a look at sort of efficient design. This is the Velodrome, where all the cycling happened, nicknamed the Pringle. You can probably tell why, because of the shape of the roof. And this was an interesting study in terms of sustainable design, and the fact that the function of the building was, I guess, a lot of architects start with a form, and then they think how to put the function in afterwards. This was very much form follows function. The function was priority. And what happened was we ended up with many, many design iterations. And the final design of that roof is quite innovative and very, very interesting. The steel cable net roof structure that you see on the bottom was incredibly efficient and lightweight to construct. In fact, that velodrome uses 30% less materials than any other velodrome of equivalent size in the whole world. Not only does it use 30% less materials in its design, but the fact that the roof is low, it reduces the volume of space within the velodrome that you then have to air condition or heat to create the environment, the internal environment that you need. So it's actually operationally very efficient as well in terms of energy. Now initially, the client, the Olympic Delivery Authority, didn't want to go with the steel cable net roof. They were terrified. They said, well, we've never done that before. We don't know how to do it. despite the fact that, as you can see there was 90% saving in the massive steel that went into roof. There was a 6-week build period as opposed to 3 months with the conventional roof, and there was almost £6 million cost saving. The Olympic Delivery Authority still did not want to build that roof. They were terrified. And it wasn't until the contractor came along and said, but we can do that, and there's a health and safety benefit to our staff. We can build the cables on the ground, and then we can just pull them into place, rather than having people welding and building steel in the air, which is a very dangerous activity. And incidentally, the Olympic programme in London was the first one that was constructed without loss of human life. And so some of these sustainable solutions are not only cost effective, but they're also positive for human safety as well, if we really start to be intelligent about the way we're doing sustainable design. And what I personally found on the Olympic Park was not that many people genuinely were interested to hear about sustainability. They wanted to know about the risk, they wanted to know about cost risk, they wanted to know about program risk, they wanted to know about health and safety risk. And so when discussing sustainability with people, to get other people on board, you need to figure out what language you use, because it may not be ecosystem services, it may not be protection for future generations. The thing is, though, once these systems are in, once these designs are done, the thing that everybody's shouting about is sustainability. I'm already running out of time. This is some of the reuse materials from the demolitions that were installed on site. Again, a small story here. I had the materials salvaged, they were stockpiled, they were on their wooden pallets, they were wrapped in plastic, and I bought some of the architects, and I kept on saying, look at these beautiful materials, please design them in. And the architects would say, no, 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 we can't, they're ugly, we don't want them. Finally, I got a few people to start using them, and the architects would walk through and see these wonderful pathways, and they were like, these are wonderful, where did these come from? I want these materials. I said, well, I've been offering them to you for the last 6 months, but you keep saying you don't want them. And it wasn't until they saw how beautiful the reused materials could be in design that they then ended up seeing the value of reuse. And I think that's what we're seeing. If you have a look around the SUP here, you see some beauty, some real beauty in the reuse of salvaged materials and the creativity that it can bring. And it also helps us to connect us to a sense of place. What would Seoul be without its historic city walls and its historic gates? It could be anywhere, it could be any city. But that connection to the history is really, really important about creating a sense of place for people as well. Sometimes unexpected materials did find their way to site. This is the Olympic Stadium. There's actually 4,000 gas pipelines that were used to create those white structures on the Olympic Stadium, which was a cost saving. Interestingly, it's not as sustainable as it might look, because when we decided that actually we were going to keep the Olympic Stadium, because initially it was all meant to be removed, although it looks like these are the same white steel pipelines, actually they've all been replaced. So in that transition of a changing project brief, it led to a very, very wasteful Olympic Stadium, and actually probably one of the most wasteful buildings that we have, even if it now has a permanent owner and a permanent use. So important to get project briefs right. During construction, some of the construction waste was segregated for good causes. You see here some of the timber being segregated, used in local schools to do planting. The bricks that were segregated, used in training and construction training facilities. Some of the overlay waste, this was the beach volleyball, and we actually very, very expensive sports flooring. You see the sports flooring here being piled up, and it went to a local gym facility that needed new sports flooring. This is a bizarre use. This was a BP pavilion. This was a dome that was used in the protection, and it was used, somebody reimagined it as a small shelter. So there's very imaginative ways that you can start to look at reusing building materials. The recycling, I mentioned that there was this incredible amount of polluted materials. Soil washing, it's like a big washing machine for soil. in fact. So anywhere where you've got industrial land, there is likely to be contamination. We generally dig that contamination out and we put it to landfill. On the Olympic Park, there was massive investment in doing things like soil washing. We've got bioremediation, which works for hydrocarbons. It basically means that you grow the bacteria that eat the hydrocarbons. Chemical stabilization, complex sorting. Complex sorting is very interesting. You actually open up old landfills and you sort out the recyclable materials. So you're salvaging what people threw away decades ago. And we had this on the Olympic Park. Huge amount of cost saved. People think sustainability is expensive, but actually it can be very, very cost effective if done well. Some of those demolition materials found their way into haul roads. Gabions, this is actually, rather than using natural stone in the gabions, we used recycled concrete. Construction platforms, again, some significant cost savings. Some other technical ways of using materials that we salvage from the Olympic Park every single time. Cost saving, cost saving, cost saving. There was some unusual recycled materials brought to site as well, secondary aggregate. The China clay industry produces a waste called stent, and for every ton of China clay which goes into paper to make it glossy, we produce 99 tons of stent. So we take that weathered granite, essentially, which is a waste stream that's generated in Cornwall, and we were able to put it in the concrete used across the aquatic centre park. It's not necessarily sustainable. I've done some further research into stent and actually looking at the implications of transporting it halfway across the country into London, even if it's by rail, actually delivers a very high carbon footprint. So sometimes the sustainable solution, the recycled solution, is not necessarily sustainable in every sense. We might be higher in embodied carbon, and it's always necessary to think about some of the trade-offs and balances when you're talking about reuse and recycling. So just to sort of summarize the statistics here in terms of the demolition waste that was created and reused. I'm not going to go through these stats in general. Apologies if you don't read English. I haven't got a hope in hell of reading Korean, so but you start to see the orange here is actually the recycled material. But you see how much waste demolition creates, how much waste construction creates, and how much waste that sort of temporary element of the Olympics created. The blue is reuse. You can see just how bad we are genuinely on reuse of waste and construction and demolition waste. And the yellow that you can barely see is actually the landfill. So we did do quite well there. So a few takeaways I think that is important here. In terms of design efficiency, material efficient design requires innovation, and it requires an agreement of risk and how risk is handled. And complex forms can actually create a lot of construction waste as well, so we need to have a look at the form of our buildings. With reuse always requires forward planning. We need to identify the end users. Before we've even built anything, we need to know what the networks and the communities are and what sort of materials they might want so that we can salvage them and we can plan for the salvage. We need to allow for time. Deconstruction takes longer than demolition. We need to allow space for those materials to be put to one side and salvaged. We need to organise logistics to get them to the people that want to use them. And actually, one of the important things as well is to brief the construction workers. You need to explain to them why they're being asked to do what they're being asked to do if it's outside of their normal job. And you'll find that they get on board when they understand that it's for local community reuse and there's an opportunity there. Waste materials such as timber, we found are always in demand from local upcyclers and charities. So waste timber is a relatively easy one. It's almost guaranteed. You can do so much with timber, and you'll find that there's a lot of timber waste from construction sites. People don't think about it, but actually if you're pouring concrete, the shutters that are used to pour concrete are timber. All of the packaging material from construction products, a lot of that is timber as well. So there's an awful lot of timber waste generated on a construction site, even if there's no timber building. And having a quick look at recycling, as I said before, most materials actually downcycled, it loses its value. A lot of the construction and demolition waste, about 50%, is actually bricks and concrete. Relatively easy material to recycle. But in order to get the value out of that, we need to make sure it's well segregated. If the bricks are mixed with concrete, mixed with plastic, then it's only ever going to go into capping or some low value use. If you want to use that concrete aggregate for road subbases, for engineered fills, it needs to be well segregated. Local reprocessing facilities are very important because the idea of transporting these heavy materials a long way to have them recycled, again, you increase the carbon footprint. So really they need to be done quite locally. Tax incentives in the UK have had a really, strong, I guess it's a strong driver to eliminate waste going to landfill and to make industry invest in local recycling facilities as well. I have gone way over my time. I apologise for that. It always happens. So last thing to say, if I can, is 감사합니다.
네, 감사합니다.